Thanks everybody for being here again on Battery Innovations in the Spotlight. We are in round number 13 now. And just to let everybody know, we have now over 1 year, Battery Innovations in the Spotlight, this monthly meeting where people out of the society, of the battery society, can meet, can interact, meet other people. People can present to this audience here. And the nice thing is that in this 1 year, we have grown a network of over 10,000 people. So I counted them up. So we reach more than 10,000 people. We are reaching every month with the network of other people who are presenting here, reaching even more. And we have in the direct mailing list over 2,000 people already. So if you're interested in getting newsletters and stuff like that, other updates, then please sign up as well on the newsletter. And I think this is a big success for 1 year to have such a network. And I can only invite everybody to simply use this network for presenting their own stuff, presenting their own companies, especially innovative stuff. It is important really that to collaborate. I think batteries are a very complex matter because you're starting with chemistry and you're ending with recycling. And there's a lot of stuff in between. And this 1 year, I've learned so much about batteries. Before I thought it was very easy. I just go there and buy them and then really using them. Now I'm knowing it's something totally different. And batteries are, I would say, one of the big markets in the future. If you can bring the sun into batteries, and you see today's energy markets, this will be a huge, huge market. And you will definitely see that as in all other industries. You see every year the prices are coming down for the energy to save the energy, and you will see technology will drive this. And at one point in time, they are efficient enough that we can really do that. And I think it's a solution definitely for the climate change and stuff like that. So therefore, this initiative is funded by the German government, to say that, and it's I think one of the very nice initiatives here. And how that comes, it's called TraWeBa. Max will start with this one, introducing this one. If you want to present yourself into this audience, we are currently going international, so reaching out to Europe. And you want to present here, please use the link. I'll show that again in the chat because I've seen there a lot of chats, a lot of mails in the chat already. And please simply apply. We simply need the email address. Don't select the data or something because we have to bring you in the order. We are presenting every second Thursday in the month. So if you're interested, please simply leave your email address there and I'll contact you. Okay, then handing over to Max and we're kicking off.
Yeah, thank you very much, Holger. And yeah, I think the more you know about batteries, the more you understand that batteries are far away from being easy to understand. And also, I will share my screen now to give you a short introduction. And yeah, maybe before we start, Holger mentioned it already. We have grown the network very successfully, and there I really want to thank Holger Geisler for the support for achieving that. And yes, we have 6 very interesting talks today, so I really want to keep it short, give you an overview what the network is doing. And we are right now funded by the government of Germany with the goal to connect companies along the whole value chain, battery value chain. And right now we are connecting over 800 of these companies. We have a lot of partners in all federal states in Germany. So we are not only able to connect you with events like this, like in a digital way, but we can connect you in a very personal level as well, because we have contact partners in every state in Germany. Let me shortly go over to a very interesting event we are organizing. And if you want to find out more about our event, what we are doing, then you're really invited to visit us at the Hannover Messe. There we are working together with our cooperation partner Niedersachsen Next Agentur and the 𝗕hes, which is a large science-focused center for electrochemical energy storage. And there on the 1st of April, we will be there and we will present our network, but also we have a lot of experts, both from science and industry, talking about different topics regarding the battery value chain. For example, the digitalization, the automatization, also the efficient battery life cycle. If you want to find out more, you can, of course, scan the QR code, or you just go to the website of the Celeste or the Hannover Messe and apply there for the meeting, because the places are quite restricted. So if you're interested, hurry up to secure a spot there. And I think with this, if you have more questions, I will always be there after the talks to discuss topics. But I think let's switch over to the pitches. You find some contact data here. And yeah, with that, Holger, back to you for the first introduction of the first speaker.
If you want to go to the Hannover Messe, please go in the chat to Alexandre Grischko. He is a guy who is working for Benelux Next. I've seen him. I just throw his name back into the chat so you see the chat. If you want to connect directly to him, just use the chance here in the chat. And we are starting, I think, with one of the very interesting or very nice overview, because we have Philipp here, Philipp Wunderlich from Accenture. The company, that's a benefit of this company. It's so big, they are seeing so many things. They are seeing the big projects. They're seeing what's coming. They're working with a lot of people on there. And they want to share their view into the future, I would say. And for this one, Philipp, I'm really excited to see your talk.
Great, thanks for the introduction, and I'm really happy you did some intro for me, because 4 minutes for a pitch is not a long time. So I will probably skip through some of the slides. You can get this later after the talk, or watch it in the recording if you want to take a closer look. But I have the honor to use this platform, present Accenture, because what most people know about us, we're a big company, I think roughly 800,000 employees worldwide, a big consulting powerhouse that operates globally. But if you go on our homepage, you will not find much about what we're doing in the battery industry. So I'm here today to share some of the insights we are doing particular in this business. Hope you can see the screen and the sound is set up. And as I said, with the introduction to the ecosystem, I think everyone agrees that that's a very challenging one that we're building at the moment. The battery with its electrochemistry is a very demanding product. It's very complex. Got underestimated a lot of times by the traditional domains. Hence, we say that interdisciplinary work is quite relevant and important. And also we as a service provider work across all the industries trying to bring this together, because that's where we see one of the major challenges, connecting the industry and working across a global value chain to kind of deliver these big projects. It's never getting boring in the battery market. So even market leaders have to be afraid to get outscaled or outpaced with innovative technology. And one aspect I want to stress is that batteries are sustainable by design. And since we're industrializing in the 21st century, unlike lead-acid batteries in the 19th century, we better use the modern tools that we have available to build this industry. So lots of Industry 4.0 solutions and digital tools, and that's what we're doing at Accenture too. I brought to you some of the market trends. Roughly giving you this overview, we see that in the markets that have battery applications, especially in the EV sector, there was a bit of a slowdown that is now being covered by the energy storage booming. But also the niche markets, so industrial batteries and all other use cases, are getting very popular simply because the companies are looking for evasion options. And if you look at the industrialization value of the value chain in Europe, there's a bit of a gap opening in the middle in the battery cell manufacturing. You will see this on the next slide. So that has a ripple effect on the upstream of the value chain, and even the downstream will likely see a shift to engineering coming soon. And Europe is currently stuck in a sandwich position between the US and China with the overcapacities that we need to absorb. So where could the market be heading? So this is the prediction for the future based on the hype cycle concept. If you followed the trajectory for the cell manufacturing, you saw a lot of announcements in 2020, and then it started that projects were put on hold, that projects went even bankrupt. And if you followed the news this week, it was even more devastating with the final bankruptcy of Northvolt in Sweden. ACC once describes the situation as the valley of death that the battery industry in Europe is currently in, and that's hopefully something we will leave soon. Our prediction is that there will be growth again, but it will be more slow than in the past. It will be less risky, and the investors are also a bit more picky on the ventures. It's going to be a tech transfer likely coming from China, more joint ventures we will see with the OEMs on the market. And many startups have to be careful to not be dropping out of the market to be replaced by Asian technology. What we're doing is offering services across the whole product life cycle, basically always using some form of digital tool to kind of add value on this, from the design of batteries to testing and even manufacturing. Circularity strategies we worked out with our clients, and as initially said, as a big company, we like also the big projects that are really challenging. Brought to you a demo here. That's an engineering demo where we're using a co-pilot, basically text to cut. As an engineer, you can say, make the battery component, in this case, 30% bigger. It will automatically update number of cells, run simulations for you, just streamline the engineering workflow. In the manufacturing space, we also did a lot of consulting in the past, especially for the gigafactories. We've seen the pain points when it came especially to the digital backbones of these facilities. And it's worth mentioning that we also have a hardware division that is providing equipment here to the industry. And the last demo I got for you is something from our test center, which is in Brunswick. So there we have a specialty test facility for nail penetration abuse tests, but also other development accompanying test. And this is a solution developed by our test engineers called Backlog that gives you direct access to the test data because our clients didn't want to wait 2 weeks until they get a PDF report. Wrapping up with a call to action already, which is talk batteries to us. So if you have problems with your clients, your suppliers, or generally industry problems that give you a headache, let me know. We can discuss the solutions with you. But if you have 99 problems but a battery ain't one, and you have only good stories to tell, like state-of-the-art software, AI use cases, we're particularly interested in this. Tell us your success story, and we might be able to open some doors for you. Because we have an extensive workforce in this field, we have a global reach, and we can kind of play the matchmaker for your industry. And I think time's already up, so thank you for listening.
Correct. I would have raised my hand a second. I know you're a coach. No, I have one quick question. You really have 100 people on the ground focusing on batteries in Germany. How much is it in Europe together?
Yeah, we don't have a clear headcount tracking on this because we also have to be aware that we can't count people full time because let's say the 100 people in Germany, they are fully dedicated to batteries. And then in Europe, in the rest of the world, they are like on and off with battery projects. I think double this, triple this, rough numbers.
Okay. Any questions to Philip? You can either raise your hand or you are opening your mic or you're throwing your question in the chat. If you're using the chat, the problem is there are a lot of comments in there plus intros and so on. Please use the chat for that. But who has a question? If there's no question, I will share first of all the link to Philip's LinkedIn profile. If you want to get in contact.
Excuse me, I have a question.
Yes.
Dion Wilder from Gamma Technologies here. I want to know, do you also have a division in Munich? Because we had some, basically we rented a software to our colleagues in Munich. Lorenz Planck did something about a swelling project with you. I wonder because you only showed Brunswick here for the test center.
Yeah, great one. Yeah, we have an innovation center for AI in Munich, and so do we have offices there. When it comes to the battery capabilities, so roughly the 100 people, we have teams in Munich also dealing with local companies. But I was highlighting Brunswick because that's where we have our hardware and the engineering core competencies.
Okay, thank you.
Any other questions?
Yeah, maybe. Hopefully a quick one from my side. The battery prices right now are pretty low. Do you have any insights how they will behave in the next years? Do they stay low as they are right now, or will they increase due to the higher demand or the reduction of production?
Yeah, a great one, and requires a bit of fortune telling. I think the general trend is further decrease of the costs. I mean, last year was surprisingly low drop in LFP prices, partially also because of scale effects in the materials and the overcapacities in China. And that was a trend that no one really saw coming. So battery price will keep falling. there will probably be more market mechanisms and modulations that might drive the prices up higher in terms of material shortages and so on. But roughly, we will see further drops in this, especially coming through low-cost chemistries. And in some, maybe in 10 years, if sodium price is a bit lower than for the lithium, we might see sodium ion becoming even cheaper than LFP at the moment. But yeah, we're doing a cost exercise at the moment for a client, checking the LFP prices from China. And it's really astonishing how they managed to get down the dollars per kilowatt hour. But to be fair, they also sell below production costs sometimes. So that's how competitive the market ended up there.
It's very hard to compete with that.
We'll try.
Please, you guys know each other, so please have a chat in between. We have to jump. We must jump to the next call. We have to reach our 8 minutes. So sorry about Simon. Sorry, Xiao. Please go directly in the chat. I can share Philip's LinkedIn link as well because we've seen a lot of other stuff. Please click on it, direct connect, and talk to him. We're coming to the second one. Benedita, it's there. I think Max, you're doing the intro.
Yes, I'm very excited to present to you or to introduce to you Benedita. She is the founder and CEO of 𝗕𝘁, which is a startup from Chile. And now that's why they are here presenting in a German network, battery network. They are actually planning to open up an office in Germany. And what they are doing is they are transforming tires into graphite and use that now for batteries. So it's a very important part of the recycling cycle. And I think that is a short overview. Benedita will give you a way more detailed presentation on it with a very nice title, 𝗕𝘁 Technology, where tires never get tired. We are looking forward to this. And Benedita, stage is yours.
Thank you, Maximilian. Can you see my screen?
Yes.
Okay. Guten Tag. My name is Bernardita Diaz. I'm CEO and co-founder of 𝗕𝘁. A cylindrical battery consists of 20% lithium, 5% copper, and 20% graphite. Problem 1. Currently, the demand for graphite is expected to grow 300% by 2030. Let me share another interesting fact. Problem 2. Every year, we produce 1 billion end-of-life tires. There are technologies for recycling this tire. Many lack traceability when it's come to their waste, such as carbon black, rubber, scrap, or carbon material. We have found a solution to these two challenges. 𝗕𝘁 is an electrochemical technology that transforms the end-of-life tire waste into next-generation raw material. This material can be used in various energy storage technology, like a lithium-ion battery, sodium battery, and supercapacitor. Our technology uses 40% less energy compared to conventional process like synthetic graphite production. Resulting is a significantly lower carbon footprint. Additionally, the raw material produced by our process delivers a 40% more storage capacity than commercial graphite. Oh, what happened? Okay. Also, our process is completely sustainable because we reuse 100% of water, 100% of the catalytic input. This addresses one of the biggest challenges in the chemical industry. Most importantly, our process generates zero waste. To put our performance into perspective, a single track tire weighs around 60 and 65 kilograms. With that, we can produce enough material for 200 Tesla battery. Alternatively, A 35 track tire could supply the material needed for one Tesla car. Sorry. The market size for 𝗕𝗫 technology begins with another material for the lithium-ion battery, which is projected to reach $21 billion by 2030. However, our technology can be applied to all energy storage technology, a market value at $521 billion by 2030. This progress has been made possible by our incredible team, which combines different skills like science, innovation, sustainability, and economy, but with only purpose, impulsing the circular economy. Finally, we invite you to join us at 𝗕𝗫, where tired never get tired. Thank you.
Thank you very much, and perfectly on time. Let me maybe start with a question. What or why are you especially interested in Germany, that you are planning to actually move there with an office?
Why Germany? Because we need to connect with technology. Germany provides access to knowledge, especially in energy storage technology material. And connect with the battery manufacturing. And right now, our CTO is studying in 𝗕𝗫 because we need to transfer the knowledge to our team in Chile. In the future, we aim to establish a team in Germany, specialists in application.
That sounds great. Thanks. Are there any questions from the audience for Bernardita? Otherwise, just, oh yeah, Paul is raising his hand.
Yes, I'm just in between. I'm sharing the link for Bernardita, so please connect to her on LinkedIn. It's in the chat. It's just now in the chat. Click on it before other messages come in. Paul.
Okay, thank you. You said the graphite you are producing has higher capacities compared to synthetic graphite. So why is this?
𝗕𝗫 technology produce an anodic material with 40% more storage capacity than commercial graphite. The conventional graphite has a capacity of 370 milliampere hour per gram. Our material can achieve 800 milliampere hour per gram in the first cycle. For this reason, it's not compared to traditional material. This is a next generation material.
Okay, so do you have an explanation to why this is?
Because when you say next generation material, you can obtain more storage capacity, because our raw material is not compared to battery grade graphite. It's a hard carbon. It's another material, but can be used in anodic.
I think you switched over already to the next question of 𝗕hes Peters. He asked, could you also produce amorphous carbon?
Sorry?
He asked you in the chat, could you also produce amorphous carbons?
Yes, amorphous carbon.
Quick answer. And another question from the chat is, what is your current production volume annually?
Current. Can you repeat the question, please?
What's your production volume every year?
No. Right now we are in TRL5. Maybe in 3 or 4 years, I would like to implement the first industry plan.
All right, thank you. I think we have time for one more quick question. I can find one more in the chat. Maybe that's then the last question. What's the capacity retention compared to graphite for long-term recycling?
Sorry, can you?
Yeah, sure. What's the capacity retention compared to graphite for long-term cycling?
I cannot explain because I don't know if our Nicholas is my CTO. Maybe he can explain the technical question.
And maybe let's, if Nicholas is there, then maybe answer the question just in the chat, because I think we have to move over to the next pitch now.
Please connect on the chat. I will share Bernadita's LinkedIn link as well. Connect to her directly. She lives in Schädel, so if you are there, visit them. And they're coming to Germany anyway, so if you don't want to travel there. So let's come over to the next talk. And we are talking about now helium-tight solutions with yes, Klaus, you're with us. So directly from Estelkamp, it's in Niedersachsen, close to the Hannover Messe. So another reminder for the Hannover Messe on the 1st of April to meet Alexandra there and the team. So Klaus, over to you. We have 8 minutes. 4 minutes. Four for the question.
Okay, thank you for hand over the micro to me. Can you hear me? At first, I like to say hello to all of you and to say that we are not Lower Saxon, we are North Rhine-Westphalia. Sorry for this. We are in the eastern north of Westphalia. Okay, I want to talk today about hybrid parts, plastic metal hybrid parts, and the special on these hybrid parts, they are not overmolded, they are not connected via screws, they are combined directly by the surface. So therefore, I will share my screen just to give you here the overview for this. Hopefully it works. I think so. Do you see my screen?
Yes.
Perfect. So what we are doing, so we take the metal part, and this metal part has a surface, and this surface get a special treatment, and we multiply the surface a lot, 1,000,000 times. That's our idea behind. It looks like in the picture on the left side then that you have this very rough structure. Don't be afraid of this structure. It's not too deep. It's only 2 microns, not more. Then we take the metal part with the structure, put the plastic part on it, heat it up over the melting temperature, and the plastic flows into the structure of the metal part. And after cooling down, it's a helium-tight connection. Here you see now a cycle of 7 seconds. This depends a little bit on the massive of the metal or the plastic inside. What is it need for? It is need for making some kind of covers for batteries. So therefore is my point to coming to batteries. So we eliminate the sealing between the pole and the cover itself. We put a plastic part between the poles and the cover. And then with our structure, we heat it up again. Then the plastic material goes into the structure of the metal. And then we have this helium-tight solutions. It is very stable against liquid. It's very stable against temperature. So every combination is, nearly every combination it's possible. It depends a little bit on the application. We can also do these kind of parts for cool down batteries or to heat them up a little bit. We can use different polymers like PPS, PPA, or PPK, polyketone. This is also a question of the specification behind the application. Here you see some different advantages for this. This is an cooling solution for cylindric battery cells. There we have a cold plate. Here you see also the different values for HTC or the thermal resistance, or if you need dielectrical coating, this is also possible. This is an integration of a complete battery box. There we put the metal sheet, the sheet metal on the bottom of the box and bonded it with our technology. This is already in mass production, and the liquid flow is under the metal part. There is the cooling coming from. We integrate a lot there, but this is another story. This is what we called high performance cold plate. There we use extruded profile to create a cold plate, which is very flexible, and also you can make it 6, or don't want to say 6, let me say half of them 3 meters long, and it has a very lightweight performance. A little bit of the tests we have already performed. We have, after some aging tests, we have performed a pressure cycling test, temperature cycling test, a temperature shock test. We have, for this application, a burst pressure of something like 8.5 bars. And we have make a high humidity test, vibration shock test, and so on. All of them are fulfilled positive, and our customers did the same test and said we can't destroy the parts. So we never get a break between the plastic and the metal. If there's something breaking, or if there's something don't stay longer, then it's in the plastic part most of the time where it comes to damage. Yeah, that's all from my side. Already done.
Very good. Thank you very much. You're a little in overtime, so anybody, any questions? Then we raise them now. And in between, North Rhine-Westphalia, very close to Niedersachsen anyway.
I have a question.
Go ahead.
𝗕hes from Gamma Technologies. Again, I have a question. Do you also do sealings or connections for fuel cell systems, like interconnectors? I hear that gas tightness is also important there.
So far, not for fuel cell technology, but for the storage of them. So there are 3 categories of storages for these kind of applications, and we are also involved in the tanks for 3 and 4.
Okay, thank you.
So we get burst pressures up to 100 bars up there.
Okay.
Fabian?
Okay. Yes. One more question, Fabian?
Yes, thank you. This is Fabian from Norvolt. Do you have any specific test regarding the mechanic failure of the sealing after several cycling, let's say, of the cell?
Yeah, it depends. So what we are doing is most of the time we do it with a pull test that we are doing. So we have special probes that we are use where we look for pull testing, and there we have just depending on how big is the area where we can do the connection between, where we have different results. But most of the time, the break is not in the interconnection. It's most of the time also the plastic is massive in that way. Yeah, it depends where the destroying part is.
And perhaps one more last question, if it's possible.
If there are any further questions, please use the chat. We are heavily in overtime already.
All right. Thank you. Thank you very much for the explanation.
Please connect directly. The link from Chris from Klaus is directly in the chat. Connect to him on LinkedIn. Talk to him the easy way. And the points I've seen in the chat, a couple of things. Hey, I have interest in technology. You're looking for investors. Let me share the link again if you want to present here, and if you're looking for investors, it will make a lot of sense that you're presenting here, because you might find customers, but you might also find investors. And if you're going there on TraWeBa im Rampenlicht, what you're seeing there, it's a pretty simple website. You're seeing these are the next dates when Battery in the Spotlight is running. So please simply go there and sign up there. And then with this one, we are coming to the next presenter. And this one, I think, it is Sebastian, correct, from 𝗕𝘁𝘁𝗄𝗄𝗄. And handing over to you, Max.
Yeah, we are going now to the very important and interesting topic of preventing thermal propagation. And yeah, I want to welcome Sebastian Way from the 𝗕𝘁𝘁𝘁𝗄𝗄𝗄. He did, I think, his master thesis on this topic. 𝗕𝘁𝘁𝘁𝗁𝘁𝘁 is working and developing some ways of preventing this thermal propagation. And Sebastian, I hand over to you. Please enlighten us how to make our batteries safer.
Yes. Thanks again. Hopefully everybody can hear me and also can see my first slide. Can you? Oh, great. Okay. Yeah, as already introduced, we are focusing on thermal propagation shielding. That means, let's see where and why we really need it. And if we look at battery vehicles, then we see they burn a lot. Let's say they burn like hell. They burn even hotter and crashing more performance than anything else. That don't mean that normal IC, that means injection combustion engine, doesn't burn, but the results of the battery vehicles are much higher. And from the actual investigations, that seems that we will see them till 2030. So what are the needs to prevent this? If you look at the battery pack, then we see the storage of different battery cells. So we can see a lot of necessary insulation space to reduce the thermal runaway from each battery and to prevent the thermal runaway from one cell to another cell. So we see a lot of applications, for example, between the cells, at the bus bars, at the modules, or even at the pack level. So we had introduced two interesting solutions for that. It's called 𝗕𝘁𝘁𝗁𝗁𝗄𝗁 Pro and 𝗕𝘁𝘁𝘁𝗁𝗁𝗁𝗁. Both solutions withstand the thermal runaway, and we can see that both solutions are resisting against the high temperatures and the strong particle resistance and even the dielectric strength. We see that both solutions have an, let's say, layered or multi-layered setup to withstand the harsh resistance. And we are focusing with these two products on, let's say, special areas. Let's say for the Pro, we focus on the module insulation or pack insulation with stronger particle resistance. And for the 𝗕𝘁𝘁𝗁𝗁𝗁𝗁𝗁𝗁, we are also able to perform busbar insulation or cell-to-cell connection or a cell-to-cell insulation. We are highly modular with the installation of this, but let's have a look at the next slides. What's the big difference against existing material? With these two solutions I've already introduced, we exist against the existing mica material. With our solution 𝗕𝘁𝘁𝗃𝗁, we are about 30% lighter and always nearly 20% better within the conductive insolution. So finally, what are the big differences of our solution 𝗕𝘁𝘁𝗃𝗁 to mica? Finally, we have the best performance for technical cleanliness. That means we don't have any particles on the surface and we can wash the surface. We have the possibility to produce extreme geometries in comparison to mica, and the handling, which you can see on the video, is still better than the brittle mica sheets. And the big advantage of all is we don't have any child labor. We can use local supply chains to produce our material. And final, in comparison with the production time, we reduce it by factor 10. Final but not least, we are also
Sebastian, you have to come to an end, please. You're over 4 minutes, so
it's my last slide. Sorry, we also focused on the recycling. Therefore, it's only interesting for everybody. It's possible to recycle and to recycle, or especially downcycle the material. Yeah, and if you have any further questions, feel free to ask.
All right, thank you very much. And there's already the first question from the chat. And Nina is asking if you provide also solutions for battery storage systems in which not battery packs but battery modules are used.
Sorry, I don't really get the difference. What do you mean between cells and modules?
Yeah, maybe I can answer the question. So battery packs are big, and I see that your cover is like as big as the battery pack of a car. And for example, we are building battery storage systems in a modular way. So we are using battery modules, and I want to ask if you have smaller mediums with which we can cover only the modules, or can you, for example, provide solution for us?
Yes, of course, it's possible. We are, of course, able to produce smaller parts, and we are also able to, let's say, produce some inlays if it's necessary.
Okay.
We have two solutions. One solution is a bit stronger, tougher to withstand also forces from the outside. But the other solution is also possible to, let's say, use it as inlay to prevent the thermal propagation and to withstand it.
Thanks.
And then there's another question from Dion.
Yes, it's me again. I have a question. Are you using any simulation solutions for the design of your plates, or is it purely based on production and experimental work?
Design is focused on real geometries. That means we have comparison geometries from our customers, primarily based on mica sheets, but also on metal sheets that normally are much thicker and heavier, and focus on these still existing geometries and RFQs. We generate similar geometries to produce.
Okay.
Hopefully, it could answer your question.
Thank you.
And I think with that,
there's the opportunity in the chat. I think 𝗕𝘁𝘁𝗃𝗁𝗁 has also shared your LinkedIn link, so please connect to them on LinkedIn. They're coming to the next session from JJ. And if you want to look into the inside of the battery, I think here's a solution, a 3D CT scan, and over to you. We can't hear you.
So, yeah. Can you hear me now?
Yes.
Perfect. Yeah, a very good afternoon or a very good day to all of you from wherever you are in the world. So my name is JJ. It's a short form for a really complicated name. We are a company spin-off from the University of Stuttgart, where we provide services and analysis to look inside your battery. So currently, the demand for making newer, better, or improve the production capabilities of existing batteries is really high. And we have found that the best part, the engineers can accelerate their processes when they have access to capabilities to look inside the battery processes, to look inside their experiments. And this is what we provided as a service. So just to give you a short overview, CT scan, go to the next slide. So CT scan is not a new technology. It's been there for 30, 40 years, but what has improved is the resolution and with the speed that we can do it. It's an expensive process. So if you want to buy an industrial computed tomography, it would cost you about 1 to 2 million euros just to have one machine. And even that machine cannot do everything. So what we found out was it is best if we can provide it as a service. So we have built our own machines, we have our own software, we use also market relevant software, and we do not sell you the hardware. What we do is when you have a question or when you have an experiment or when you have a specific task where you want to look into your battery, we go out and do the experiments for you either in our machines, or we also do it on the synchrotrons, which are like the laser sources for X-rays. So generally the process works in such a way that you have X-ray images from very different angles, and then you put it into a reconstruction algorithm, and then you can see let's say a 3D volume of the batteries where all the inner structures, the electrode, the layers, and everything are visible. Just to give you an idea about it's not just images that we provide, we can also quantify. With this image, we were at the cover for the Battery Journal in 2021, where we first showed out the sinusoidal expansion of lithium-ion cells. And currently what we are working on, so here, we did a CT scan before a charge, a state of charge, and a scan after 100% state of charge. And the lines, the green lines here show the expansion or the compression when we put two scans on top of each other. And this shows a really not only places where the cells expanded, but also places where it is getting compressed. So it's not only a 2D part, it's also a 3D simulation where you can see where the parts is compressing. That is particularly important for modules and big packs. What we also do is a lot of process production process optimization. Let's say you have a specific production process. In our case, let's say anode overhang or electrode placement, electrode thickness. We can do a scan. We have our own AI software that can automatically detect and segment it and also find out the anode overhang automatically. Another example would be laser welding of contacts. As you know, welds produce a lot of pores, and this in order to detect and in order to give you a proof that your process is working or how do you improve it, this is really helpful. Yeah. So what we do is currently we provide CT services with advanced analysis. So if you want to see into your batteries, do feel free to contact us.
Very good. Any questions? Perfectly on time. Anyway, hang on. When have you started doing this?
So we started building our machines 10 years back. It took us almost about 5 years to bring the machines to state of the art without the capital that is generally required. But we are providing the solution since 6 years now. And we also go to synchrotron. So these are like high power sources where we do complete battery packs. So if you have a sensor in between, or there are people who are doing abuse tests, so we scan the module before and after. Unfortunately, I cannot show you all the results, but any kind of time series, state of health experiments, we can help you look inside, or electrode expansion. Yeah.
Okay, we have, I think, 1, 2, 3, 4 questions in the chat. One is, how much is the price for a scan, I think?
Yeah, just maybe to, let's say you do a typical scan of a cylindrical cell and just for geometry, and when you do a more advanced analysis, what is the price scale in which you operate? Because you said 1 to 2 million for a machine. How does it compare to your services?
So I would say it would range somewhere by 500, 600 euros. But if the number goes on increasing, we use a lot of automation process to bring the process down. So we are doing up to, for local companies here in Stuttgart, the big manufacturing, we can achieve also costs something like 50 euros per battery cell, where the battery numbers are close to a few thousand cells.
Okay, there's one other question called, what is the best solution capabilities, ... So Robert, maybe you can frame your question yourself.
Yeah, the resolution, the best resolution in CT X-ray. So what is the smallest feature you can resolve?
So it depends on your module. So there are a lot of X-ray physics behind it. We can have a look at, let's say, at a dendrite level, in a nanometer level, at a picometer level, but you have to also think about your field of view. So if you're just looking at electrode structures or graphite structures, then we have a different setup. Rather, when you're looking at a 90 kilo big battery pack where you want to achieve the electrode resolution. So it depends on the battery pack itself. I cannot give you an exact answer, but we can achieve resolutions up to, let's say, 20 nanometers also with some samples.
Okay, I think that answers the question. So therefore, we're coming now to the, so thanks for your time, the presentation, were very, I think, interesting. Let's come to the last presentation and handing over to Max for this one. And in the chat, there's JJ's LinkedIn link, the last chat entry, so connect to JJ.
Thank you.
Yeah, and now I want to introduce Olgers from the OP Mobility. It's a French company, and they are tackling quite a difficult but important task of zero-emission mobility. Quite a big company. They're doing both battery and hydrogen approach. But today we get an insight in what they are doing for the battery part of the zero-emission mobility. And I think especially they are focusing on heavy-duty vehicles.
Perfectly. Yes. Hi. Hello, everyone. Could you see my screen?
Yes.
Yeah, perfect. So, hello, everyone. So today I will focus more on our e-Power business unit, focused on battery. And I wanted to talk about flexibility. It's not technical presentation, but just you know, this side of e-Power, the flexibility. So we know that in the market of battery provider, there is a strategy of push market. So we produce a battery pack and we push to the market. We have both, let's say, solutions of battery where we have now off the shelf that we can propose to our customer, but our expertise is more to adapt, personalize, and design a battery pack for the customer needs, and that's why we are talking about flexibility. So first, flexibility in the sector. As you could see, we are providing battery packs going from 48 volts up to 1,500 volts. So it's big systems going from light passenger car up to the big dump truck for mining, for instance. And what I can say is we have a particular expertise on railway market. Why it's important? Because as of today, what we see, railway market, it's most demanding in terms of standards and norms. And that's why when you know how to treat with railway, you can easily expand to other markets, which are as well highly demanding, but not as the railway. So in this case, we are highly flexible. Let's say when we design the pack, all the innovation solutions that we implement inside, we can replicate to any size of battery, any application. But not only because we are a chemistry agnostic company. Let's say we work with all chemistry. We don't focus only on one, particularly like LTO, NMC, LFP, or sodium-ion. We propose, depending on the need of the customer, the best chemistry which is fitting to the need. And today, as an example, we are also looking to the market for new chemistries, sodium-ion, where we invested some money as well to 𝗕𝘁𝘁𝗿𝘆, where we are waiting for some results. Flexibility, it's not only about battery pack, but also the business model. Today, we, OP Mobility, we have a flexible business model, meaning we can provide a battery pack which is plug and play from the design to manufactured by us at 100%. But we see as well on the market that customers are sometimes interested to co-design or totally to produce their own design. So we, thanks to this footprint of OP Mobility and this industrial excellence, let's say, we can provide to the customer as well multi-print, directed component productions. So it's really depending on the needs of the customer. So one of the last things, it's the total in-house software development for the battery management system, which allow us to really to provide the personalized solutions to our customers. So we, in this sense, we are quite flexible. And as I told you, we are chemical agnostic. So I guess that's it. I did it really short to give you an overview. Don't hesitate if you have any questions. Thank you very much.
Okay, thank you very much. That was definitely in time. Actually, you saved quite a lot of time for the discussion. Let me start with the first question. You talked about the flexibility. Where is it starting in your company? Do you want to have the flexibility already on the cell level, or further down the road?
So when I say flexibility, actually it starts from the specification of the customer, the needs. So we can consult the customer what is the best, and when it comes to the cell chemistry, we select jointly with the customer what is the best one. So we are not pushing one of the solutions absolutely, like you need LTO or you need NMC. We really evaluate depending on the specification what's the best fit, and we can select several solutions, let's say options, what to propose. And meaning today we have a panel of cell providers which are in partnership with us, and we can select from even inside a chemistry different provider.
All right, thank you. And are there some questions from the audience? Okay. It seems to not be that case. Maybe, Uljas, do you have a call of action? What do you want to, maybe with whom do you want to get in contact? What do you want to achieve in the next year, or maybe the next 5 years with your approach?
Yeah, so I mean, the first interest is of course to connect with OEMs.
Oh, you're muted.
I am muted. Sorry. Yes. No, I would say as the first intention is to connect with OEMs to provide our solutions, but not only. If and I see in this audience we have a lot of potential partnerships to establish to implement some innovation into our battery pack. So we are quite open to get the best state-of-the-art technology on the market for our customers.
Right. Thank you very much. I think if there are no further questions from the audience, I thank you all very much for your attendance, for your attention, and hopefully see you all again next month when we have the next battery innovation session, and it will be on the 10th of April.
4:30 again. So please log in. I think there should be on the web page, there should be also the newest thing in there, so you can already, I think, log in. So would be great to see you there as well. And I would say thank you to all the participants and as well as to the speakers, Philip, Bernadita, Klaus, Sebastian, JJ, and 𝗕hes. I think it was a very nice discussion here, and please, and I think we have seen it this first time this day. It was really great that you're using the chat really to connect, because that's what it's all about. So let me share, last but not least, my LinkedIn link. So connect to me if you want. So we are doing really scalable B2B sales, and that's really something you can achieve via LinkedIn. And that's the way how we design and how we have built this 10,000 people strong network. And I would love to see you again next time. And do not hesitate to collaborate with each other. Yeah, thank you, everybody. And if you have a few minutes time, please stay on the line, and we simply want to collect some feedback.